All right, let's take a look at chapter 3.2, subtraction of whole numbers, understanding subtraction of whole numbers. Number one asks us to make up a subtraction story for each of the following contexts. Briefly explain why the story problem is an example of the particular model. Okay, let's start with A. The takeaway model. Let's use the numbers 3 and 2 since they're here for us, 3.2. So 3 take away 2 is then our goal, right? So we want to have 3 of something and then take 2 of that exact same thing away, right? So let's see. Ash has 3 hamsters. He gave 2 hamsters to his brothers. How many hamsters are left? And if we took a set model, right, and we had, for example, the 3 hamsters, what we also have then is 2 of those hamsters being taken away. Okay, so this is a takeaway set model. And we could also show this using a linear model. So 0, 1, 2, 3 hamsters. Where Ash has 1, 2, 3, and we take 1, 2 away. Okay, let's take a look at the next type of subtraction problem that we're going to build. That's the missing add-in. If we stick with the numbers 3 and 2, then missing add-in is of the variety that we have 2. We want to add some amount and have the result of 3. So again, these will be the same units, right? So we could have something like I have $2 saved up for our Friday bake sale. I need $3 to buy that delicious brownie. how much more do I need? So you're looking for the missing add-in, which is why we have this structure here. And in comparison, we have, let's use our numbers 3 and 2. Let's see. Jackson has 3 toy cars and Lee has 2 toy cars. How many more cars does Jackson have than Lee? So we could represent Jackson's cars and we can represent Lee's cars and have a comparison model. We asked how many more cars does Jackson have than Lee, but we could have also asked how many fewer cars does Lee have than Jackson, right? So we could have worded that slightly differently. Now, having practiced the different models, let's decide which ones in number 2 are which. So let's bring our 2 up. Okay, which of the models of subtraction best illustrates each of the problems? Rena had 25 quilts and sold 10 of them at the show. How many does she have left? That appears to be the takeaway model, right? If we have 25 of something, these being the quilts, then we can take 10 of those quilts away to represent the sales. And how many does she have left would be the uncircled amount. So this is takeaway. Part B reads, the hall holds 100 people. Currently 65 tickets have been sold. How many more tickets can be sold? This is the missing add-in for B. We have 65 already, and we can sell up to 100 tickets. So how many more tickets can we sell? And C is the 6th grade has sold 58 raffle tickets and the 5th grade has only sold 45. How many more has the 6th grade sold? So for this one, I'm going to do a couple number lines because we are comparing, right? So if we didn't answer that, but this one will be comparison. And I'm going to use a linear model. So we start with 0, right? And let's call that 10, 20.
You want this?
No, thank you.
Thank you for the food.
You're welcome. 30, 40, 50. I need a little bit longer lines. Or 60. Okay, on the first line, we'll plot the 5th grade sales. And on the second line, we'll plot the, oh, I guess I should put 6th first, but that's okay. We'll put the 6th grade next. That makes sense too. Now, let's plot the 58 tickets for the 6th grade. So we need a base 10 breakup here. 1, 2, 3, 4. 1, 2, 3, 4. To find the 58. Oh, to be right there. So we have this distance. For the 6th grade. And now for the 5th grade, we have 1, 2, 3, 4. 1, 2, 3, 4. We have the 5th grade here. So by comparison, we have 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13 more in the 6th grade, right? So by comparison, I counted from the 5th grade until the 6th grade to find that there was a difference of 13. So that was by comparison. So we have a linear model by comparison. We have our missing add-in equation model, and then we have a set model for the takeaway. All right, let's take a look at for 5 and 6. 5 is explain why the operation of subtraction is not commutative, and explain why the following operation of subtraction is not associative. I said following, but there's no following. Basically, explain why we don't have those properties. So let's take a look at 5. Then they also wanted us to do parts of 6. So we'll keep 6 around as well. And all of that is 6. So let's keep that. Okay, so what they're saying with the commutative property is that we can't change the positions, right? So let's look at the commutative property for addition. That says that A plus B equals B plus A. Also in multiplication, we have A times B. It has the same value as B times A. right? So we have the commutative properties for addition and multiplication, but they want us to show that there is not that property for subtraction. Okay, so let's take a look at subtraction, right? If we had, pull from one of those over there, if we had 70 minus 23, right, that has a value of 47. But if we tried to switch the places, leaving the operation where it is, 23 minus 70, then we have the negative value, right? And you might think the negative stays with the 23, but you're thinking in terms of addition. You're not thinking in terms of subtraction. Subtraction is an operation and it stays right there where we wrote it, right? Is what they're trying to get us to do. So okay, so what we have is that 70 minus 23 does not have the same value as 23 minus 70, right? So therefore, subtraction is not commutative, meaning you cannot just move the terms around, leaving the operation where it is. Okay, so subtraction is not commutative, right? And we showed that using a counter example. So we just found one instance where it doesn't hold, therefore it doesn't hold. Okay, now let's look at the association, right? So let's clear this out. For association, in addition, that looks like A plus B plus C has the same value as A plus B plus C. So here we have the A plus the quantity A plus C versus the quantity A plus B plus C. And what we say and show is that these have the same values, right? We use the snap together blocks and stuff like that. In multiplication, we have that A times B times C. So if we did A times B and then multiply it times C, that would have the same value as A times the product of B times C, right? And we see this a lot when we look at length times width times height, right? Sometimes we do the length times the width, which is area of the floor, and then we stack it to the ceiling, versus sometimes we find the area of the wall and then we stack it through the room, and those have the same volumes, right? So in multiplication, we have this version. In addition, we have this version. And in the blue, we have associative. And you're just associating the multiplication or addition with a different term. You're not physically moving it, right? So let's try and do, so let's look at a subtraction. Such a weird way to like write it. Let's try 50 minus 20 minus 3. And then we'll try 50 minus 20 minus 3. Okay, so in order of operations, this is then 50 minus 17, right? Which is 33 versus 50 minus 20, which is 30. Take away 3 gives us 27. Right, so let me just double check. So we've shown that 50 minus 20 minus 3 does not have the same value as 50 minus 20 minus 3. Therefore, right, let me get this out of our way real quick. So we can conclude that subtraction is not associative. So you can move the terms of addition and multiplication around, but you can't do that to subtraction. You can also reassociate what you want to do first in addition and multiplication, but you can't do that in subtraction either, right? And of course, behind the scenes, we view the negative being distributed, and we're always sort of thinking in addition because of things like this, like subtraction is not associative. But if we distributed the negative, or if we, did things like that, then we would have the same answer. So as you force yourself to leave the symbols there, recognizing their operations and not negative numbers, then you can show this counterexample or some counterexample. Okay, for number 6, we're told to look at HIJ. Here are these. There are these below. And what they want us to do is use things like linear models, potentially to show these type of things. So hold on, I kind of messed it up. Okay, determine these differences mentally other than by the standard algorithm, right? And so how would you go about solving these, right? 145 take away 98, that could be like 145 take away 100 and then add 2 because we added 2 to get to 100, right? So 145 take away 100 and then add 2, that would give me 45, add 2 is 47. So if I was to write it out a little more slowly, for example, I might have written 145 minus 98 it's a weird thing to write, but plus 2 minus 2, so that in math, we're just adding this secret 0, right? And so mathematically, we combine the negatives to make a negative 100, and then we have that compensating 2 there. Another way to look at it, let's see. So we have 145. We want to take away 8. So if we quote unquote add 2 to this number, then we add 2 out here as well. But like I said, adding 2 to that number means we're taking away 2 more. So it's a little tricky when you try to show all the inside bits, but basically that value is so close to 100 that you may as well just take away 100 and then finish the compensation, right? And we have a value that's very close to 400, right? So 815, take away 400, but we had to add 1 to this. So we're going to add 1 to the whole thing, because adding 1 to a negative meant subtracting 1, actually. So here we're going to have 415 plus 1, right? So 416, for example. H-I-J. My J's always look like weird L's to me. J. Okay, let's see. J, there you are. Okay, so in J, what can we do, right? Well, the easiest thing I think would be 562, take away 230, right? It's not 100, but it's like the nearest 10. And we only added 2 to make that happen, right? So take 230 from 562, and we're left with 332. And then we're going to add 2 for resulting 334. Sorry. 334. Okay, so number 15, 17. So let's next page. Okay, through illustration, demonstrate how to solve these problems. Okay, perfect. Okay, so base 10 manipulatives is generally what we have to work with. So 15 and 17. So maybe let me E, F, G. I'll just come back for it. Okay, so 15. So we'll move B over there in the corner. And always what we need, I'm gonna move this down so I can start a little higher. Okay, so let's start by making our base 10 shorthand. We need that key. So we'll need units, tens place, and hundreds place, where a unit is 1. A group of 10 units is 10, and a group of 10 tens is 100. Okay, so what we have then in 524, take away 268, we have 5 hundreds. So you want to show the original value, 2 tens, and 4 units. Our second number has 2 hundreds, 6 tens, and 8 units. And we want to do subtraction, right? And so what we have here is we start in the ones place. We try to take 8 units away from 4 units. We can't, right? So we're going to borrow. When we borrow a group of 10, right? So we have a 10, which is 10 units. So we'll put our 10 units out. And now we can take away the 8 from below. Leaving us with the 1, 2, 3, 4, 5, 6 units. Now we're going to try to take away 6 units from the one blue, or not units, but 6 tens from the one blue 10 that's sitting there. And we can't, right? So again, we're going to borrow 1, but borrowing 100 gives us 10 tens, right? So we have 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we can take these 6 green rods away. So we'll do 1, 2, 3. That's 1, 2, 3. Then another 1, 2, 3. Gets rid of these 1, 2, 3. And I'm left with 5. 1, 2, 3, 4, 5 from above, right next to my key. And now I'm going to try to take away these 2 hundreds from the image above, which I can. And I'm left with 2 blue squares, right? Now, if we do the standard algorithm, we can see that we're going to follow the same steps, right? Let me try to resize this a little. So we have our 524 next to the blues, our 268 next to the greens. And in our standard algorithm, we try to take the ones away first. And so we have 8 that we're trying to take from 4, and we can't. So we borrow 1 from the side group, which gave us 14. Now we can take 8 away from 14, which leaves us with 6. Now we're going to try to take 6 away from 1, which we can't. So we'll borrow 1 from the next group. We bring that over as a 10. Now 6 away from 11 is 5. And finally, we take 2 away from 4, which is 2. And in the end, we have 6 units, 5 tens, and 2 hundreds. Now for B, right, which is right here, we're going to have to do some steps of trading out, right? Let's start with 6 hundreds. So we have 1, 2, 3, 4, 5, 6. From that, we want to take away 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3, 4, 5 units. And that's the amount we want to take away. So the green is going to try to come out the blue. We first try to subtract the 5 units and we can't, right? So to start with, we're going to borrow one of the symbols that we do have, right? Which we're going to turn into or regroup as 10, 2, 3, 4, 5, 6, 7, 8, 9, 10 rods. Now we have rods, but we're still just trying to take away these units, right? So now what we're going to do is we're going to have to trade out one of these. It's under my picture though, so I don't know how well I'm going to do it. Borrowing. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now I don't necessarily like how the arrow looks, but like I said, I'm kind of writing under my my videos feed, so it was hard for me to draw that. Okay, so now I finally can take 5 of the green away from 5 of the green units away from the above image. I'm not going to be able to show that borrowing. So actually, let me erase this stuff down here. And then I'll catch up. Okay, so I'm going to move this one over. Get rid of this one. And right, and then I'll catch up with the drawing. So 1, 2, 3, 4, 5, 6, and we are trying to take away 1, 2, 3 hundreds, 4 tens, and 5 units. Okay, so we tried to take away ones and we couldn't, so we regrouped. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Still trying to take away the ones and we can't. So we're going to regroup, right? And that's going to give us 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 for 10. Okay, so now I'm caught up with that other image. I'm going to erase it. Okay, so at this point, we were observing that we can actually take ones away now, right? So we have 1. Oh, I didn't want to take it away like that. Well, let me put those back. Come back. Oh, undo, not redo. Okay, now I want to take 5 units away. And I have, that leaves me with 5 units. Now I want to take those 4 green rods away, right? So 1, 2, 3, 4. 1, 2, 3, 4. And that leaves me with 5 rods from above. And now I'm going to take away 3 hundreds, which leaves me with 2 blues boxes from above. Now, if we were to show this algorithm in the standard algorithm here, we would try to do the same thing. 5 away from 0, can't do. So we move to the next column, can't borrow. We have to borrow from the hundreds column, which leaves us with 5 hundreds and 10 tens. Now we can borrow a 10, which gives us 9 tens, and we're going to borrow the 1, right? So we have a 1 0 now, and we're going to take 5 away, which leaves us with 5. Take 4 away from 9, leaves us with 5, and take 3 away from 2. Oh, I'm sorry, 3 away from 5, which leaves me 2. And I have 5 units, 5 tens, and 2 hundreds. Notice a few things that I did to try to be consistent. I tried to use the one, I gave the top value its own shading and coloring. I gave the second value its own shading and coloring. I used the black ink to indicate when I was borrowing and regrouping, right? And so that's part of our vocab there, is to borrow and regroup. So we borrowed and regrouped using the black ink, and we actually did the takeaway using the yellow, right? Another thing I did to be consistent was I tried to cross the images out as they were. So for example, in the units, I have 3 crossed out in the top row, 2 in the bottom, and I have that same pattern. And then when I bring the 5 units down to the solution area, I tried to represent them the way they were represented above so that the reader could easily find them. Right? So be as consistent as possible. As you can see here, this is the book's representation. It's all in the same color. There's no key because the key is understood to be the base 10 representation of these numbers, right? The base 10 shorthand. So in their images, they did the regrouping in one image and then the takeaway in another image. I did it all in one image. You can split it into as many images as you want. You can show the first borrowing in one image, redraw, draw the second set of images where you borrow again, redraw, right? And then draw a solution where you're actually doing the takeaway. But what helps is they've separated out in their using one color when they're borrowing and regrouping versus when they're doing the takeaway. So if you recall, I had tried to express these 2 steps using the black ink for the regrouping step and the yellow ink for the takeaway step. So I suppose I would want to let the reader know that I was doing takeaway when I was doing the yellow cross marks. In their version of the answer, as I was saying, they have their borrowing and regrouping images as step 1, where they show then crossing out an image and regrouping, right? And in their second step, then they have the takeaway step, which they're crossing out marks this time represents taking away. So whereas I represented it with two colors, the book represents it with two separate images. These crossing out marks mean regrouping. These crossing out marks mean takeaway. All right, let's take a look at number 17, E, F, G, and H. As you might expect, there are many more ways in which children make mistakes in subtracting than in adding. What is the child's mistake in this problem? What aspect of subtraction or place value is the child not applying or applying correctly? Okay, so in E, right, we have 70 take away 48 with the result of 32. And so what the student hasn't done correctly, right, is renamed 7 to 6 when they borrowed 1, right? Getting 10 on this side. Okay, so this student didn't rename. Let's see, too fond of the yellow. In F, what we have is 700 take away 482. So it looks like here what happened, the student did borrow 1 from the 700. So I'm just going to write it beside so I can write it big enough. So they did borrow 1 from the 600, but they gave it to both, right? So then they got an 8 and a 2 and a 2 for 228. So here they borrowed, but gave 10 to both place values, right? In G, the student is borrowing, but they aren't taking it away from the place value and renaming, right? So for G, we have 364, take away 79, right? And what needs to happen is when we borrow from our neighbor, we rename and then give carry the 1, right? Then give that to the 1's place. Now, when we borrow from our neighbor and get that 10, it's onto the 5 that was renamed. So we have a leftover of 8 and then the 285. So here we have borrowing, but not renaming, right? And then for H, we have 32 take away 29 with the result of 17. And so what the student's done is just made the subtracting more comfortable. So they switched the 9 and 2 around and subtracted the 1's place so that it was more comfortable to them. But then they didn't need to do that in the 10's place. So they had the resulting answer of 17 instead of doing any borrowing and regrouping, right? So here, no borrowing or regrouping, but they did rearrange the numbers just for ease, right? And let's see, what's the next one? 22 and 24 AC. So there's 22. That should look like the beginning of the semester, right? Find the missing digits. And 24. Well, I definitely think 22 looks like a game, and 24 looks like stuff that we have been focusing on in class with the different bases. So let's go ahead and take a look at 22 and 24. I might save 22 actually for class on Wednesday. So let's do 24. And we don't have to do all of them. We just have to do A and C. So just one of the base 6s and one of the base 8s, right? So here, okay, so find the differences in the given base. And I'm going to write it below so I have enough space. So A is 4, 1, base 6. Take away 2, 2, base 6. So we're going to use the standard algorithm for stacked subtraction. We're going to try to take 2 units away from 1 unit, and we can't, right? So what we're going to do is borrow 1 from our neighbor, but that 1 is a group of 6 units, right? So I often will cross the 1 off and write 6 plus 1, which is 7, right? So if we have 7 take away 2, now we have 5, and 3 take away 2 is 1. So 24 is 15 base, oh, sorry, 24A is 15 base 6. Now for C, right, we have, I'll spread it out a little, learning from what I did on the other one. Take away 3, 6, 4, also base 8. And to begin with, we start in the unit spot. We try to take that 4 away from 2, and we can't. So we're going to borrow 1 from our neighbor. But this time we're going to bring over 8. So we have 8 plus 2, which is 10. 10 take away 4 is 6. I'm going to write my little base 8 notation down. Now I'm going to try 6 away from 3, but I can't. So I'm going to borrow from my neighbor. And this time I'm going to bring a group of 8 over. So 8 plus 3. And I'm going to take away 6, which leaves me with 5. And finally, I take 3 away from 6, which gives me the value 356 in base 8. And then let's just double check these with the grade book. So A was 15 base 6, check, check. And C was 356 base 8, check, check. So when you're borrowing 1 from your neighbor, but it's coming over as a group of the base, right? So the base is your grouping number. Let's see. So I think I might have a little time to do 22. Me as well, right? It's the last one. And then we can catch up in class with anything else we want to talk about. Let's see. So here, these are all base 10 numbers. I'm going to spread them out a little. So looking at A, we have to have the result of a 9 when we take this away, right? One thing that you might use to your advantage is that you know that the difference plus your added, right, equals your other. And that's not the addend, actually, that's the subtrahend, right? Okay, so we do have this situation, right? And so when you flip it like this, you might be able to see different patterns, right? So let's see, the 8 and the 6 are solid, right? So I think we had, let's see, a 7, right? 9 plus 7 gets us to the 6. And then we would carry the 1 for 6, 7, 8. And then in the next column, there's nothing to carry. So we just have 3 plus 5, which is 8. And so this is 886. Take away 567. And if we're correct, then we should have, oh, sorry, a value of 319. And if we wanted to show all the steps, we would show our taking away and carrying. But now you have to very clearly reinsert your answers, right? So doing the carrying and whatnot actually made the image more crowded. And so I will box as they've boxed. Oh, that was the eraser though. I will box as they boxed. That way when the reader is just glancing through this, they'll see 857. And that's what they're looking for, 857, right? Let's look at B, right? So if we play that same trick, right, we could try to flip it. We could try to say that 4, 5, 6 something plus 6, 4, 8 is 5 something something 3, right? 8 plus 5 is 13. So we have 5 here and we have to carry the 1. 6 plus 4 is 10, plus 1 is 11, right? 5 plus 6 is 11, plus 1 is 12. Carry the 1, we get our 5. So reverse it back so that you write it in the correct way. 5, 2, 1, 3, take away 6, 4, 8 is, if we do the work, right? 8 from 13 is 5. 6 from 10, 4 from 10 is 6. And then 6 from 11 is 5 with a 4 in the thousands place. To make it more obvious to the grader, you want to box. They have boxed because the grader is going to be looking for 215, right? That's how they're going to grade it. 215. Okay, check. So what we're doing below the problem is the showing our work step. And what we're doing beside the problem is reiterating what it would look like back in those terms. Okay, so our last one, and then we'll stop for the day. We have something 6209 plus 2 blank 1 2 blank, which gets me 8 2 blank blank 6. 9 plus 7 is 16, right? 2 plus 0 plus 1 is 3, no carrying. 2 plus 1 is 3, no carrying. 6 plus something equals 12, right? So 6 plus 6 equals 12, carry the 1. And now we have 3 plus something equals 8. That would be the value of 5. Rewriting it, we have, I'm going to write it a little lower so it's below my picture. but I have 8, 2, 3, 3, 6. Take away 2, 6, 1, 2, 7. That gives me the value. If I do the math myself, I get a 9, 0, 2, 6, 5. Now I'm going to box it the way they boxed it, right? We had those 3s missing. We had that 6 and 7 missing and that 5. And again, the grader is going to come looking for 3, 3, 6, 7, 5. So that's all for today. I'm sorry that I had to pre-record class for us. As you know already, though, I had a doctor's appointment for one of the kiddos. So let's see. That's not clearing out for me. But I guess I'll just leave it. So I'll be on campus on Wednesday. We have 2 inaction problems left, and we're in 3.2, not 4.2. So section 3.2, inaction problems, right? So look at 1 and 2. We can discuss anything else from section 3.2, but we did look at all of the book exercises. And otherwise, I will see you Wednesday, right? Thank you.